All right, guys, today we're going to look at some applications of matrices by evaluating determinants and applying Cramer's rule. First of all, these are called determinants. Notice they're both square. That's important. Only square matrices have determinants. And you'll see straight bars instead of the brackets we usually see on them. You'll see straight bars, which is a little bit of a change. Move that over just a little bit. For a 2 by 2, all you do is very simple. All you do is you multiply. Let me get my highlighter here. There we go. I'm going to multiply this direction right there, that diagonal, and then I'm going to multiply that diagonal, and I'm going to subtract. That's all you do. So I'm going to say 5 times 1 is 5, 4 times 3 is 12. You always subtract. Your determinant's -7. All there is to it. A 2 by 2, very simple. 3 by 3 gets a little bit tougher because there's a little more calculation involved. What you have to do first is recopy your first column out here and your second column out here. Not your third one, just your first two. I'm going to go to the same method. I'm going to go diagonal that way, and diagonal that way 3 times and just multiply. So I'm going to do my first diagonal, that's -4. My second one is 0 because there's a 0 in there, and my third one is 48. All right. Then I'm going to take another set of diagonals. I'm going to start at the other end and go this way, and this way, and I'm going to multiply those. The only difference is when I multiply those, I'm going to subtract, go in that direction. So I'm going to go -8 minus 0 minus -9. And all you do to get your final answer is just add all those numbers together. And when you do that, add those all up or subtract, or whatever the case may be, you get 45. That's your determinant. Now, one thing about a determinant, it is a 1-number answer. You're not going to get another matrix, you're going to get a 1-number value. And one thing weird about doing that process on a 3 by 3, you may not recognize, every number up there I use 2 times. I know it doesn't look like it, but if you really look at that number, it got hit twice, and I will show you that in class tomorrow if you don't see it. But so a 2 by 2, real simple. 3 by 3, not hard, just a little bit longer. Okay, one use for these determinants is you can find the area of any triangle on any coordinate plane without knowing the base and height. As long as you know what the vertices are, you can use this right here. You can use that area formula, which is 1/2 the determinant of all 3 points. Notice the last column is all 1s. And if you put your points in these first 2 columns and all 1s and take 1/2 of that determinant, that gives you the area of the triangle. Pretty neat thing. Let me show you one. Okay, this one says find the area of a triangle. I'll put some big numbers in here, which is a mistake on my part. But I'm going to take the first point, -1, 41, put it in there. The second point is 0, 0, thank goodness. The third point is 38, -43. And your third column is always 1s. And we're going to put a 1/2 in the front as a scalar. Now, I probably should have put straight bars there because it is a determinant. That's what I'm going to work out. So I'm going to recopy my first column. I'm so happy these zeros are there. Recopy my second column, and you'll see why in just a second. And I'm going to work through there. First of all, I guess I should bring down the 1/2 because the 1/2 is going to be in the front of everything. So let's do this. I'm going this way, this way, this way. And the cool thing is when I do that, the first one, because it has a 0 in the diagonal, is 0. The second one also, what does it? I have 41 times 38. So I'm going to have to work out the 41 times 38 on my calculator real quick. 41 times 38 is 1558, which is a pretty huge number. And then my third diagonal also has a 0. Then I'm going to go the other way. I'm going to go, let me change colors. I'm going to go this way, this way, this way, and do the same thing. Going to, except I'm subtracting, remember, so I get a -0, -43, and a -0. And once you get all that set up, you can just finish working it out. So I'm going to go 1/2 of whatever's inside there. What I have is 1558 minus 43. And which is 1515. I forgot the 1 in there. 1/2 of 1515 is 757.5, and that would be the area of that triangle. Now, this is really just unit squared, which is fine. Also, one thing, I don't know if you remember about the last slide. If you were to get a negative number in here, you remember you cannot get a negative area. That's why if you looked at the formula earlier, it actually said plus or minus in front of that 1/2. And you have to pick which one to use. It's whichever one will make your area positive. Okay, the last thing today is called Cramer's rule. Cramer's rule is a way to solve systems. I think it's really neat. I think a lot of you will really like this way to solve systems. If you have a system like this is what Cramer's rule looks like. And I'm going to be honest with you, I'm going to give you a good way, a gesture way to remember this tomorrow. But anyway, if you're looking for x, what you're going to do is you're going to do a 2 by 2 determinant on the top, and you're not going to use the x coordinate, the x coefficients. You're going to use the e and the f instead, but you are going to use the y. On the bottom, you're going to go the coefficient, what we call the coefficient matrix, which is a, b, c, d, because they're always coefficients. The same thing on the y, the same denominator on the y, a, b, c, d, the coefficient matrix. But on the y, the numerator is going to be the x coefficients there, but instead of the y coordinates, you're using the e and the f. So when you're looking for x, we're not using the x coefficients, use the e and the f instead. When you're looking for y, do not use the y coefficients, use the e and f instead. The bottom of both fractions is the coefficient matrix, just coefficients. I'm going to show you one of these. Okay, we have one here that says solve that one. And it's going to say in your book you must use Cramer's rule. So here I go. I think you're going to like this, okay? X equals, now, in my denominator, I'm just going to put my coefficients, 9, 4, 3, negative 5. In my numerator, because I'm looking for x, I am going to use the y coefficients, but I'm not going to use the x coefficients. Instead, I'm going to use the constants on the other side. I'm just going to work these out. On the bottom, I get negative 45 minus 12. Just doing the determinants like we did earlier. That's 30 minus negative 84. So it's going to give me 114 over negative 57, which is negative 2. Guys, that's your x already. So now I'm going to do the y. Now the beauty of the y is on the denominator, I should have the same coefficient matrix, and I've already worked it out, and I got negative 57. So I don't have to do that anymore. In the numerator, I am going to use the x's coefficients, but I'm not going to use the y. I'm going to use the constants instead. And when I multiply, I get negative 189, I believe, minus negative 9 over negative 57. I'm going to make sure I did that math right real quick. No, I didn't. 9. Okay, I found it and fixed it. I thought that was a 1 of the 7, negative 6 right there. So it was really a negative 18. Went back and fixed that one. So if you add those up, you end up getting negative 171 on the top, negative 57 on the denominator. If you divide that, you get 3. And guys, that's your solution. There's your x and your y. So my solution is negative 2, 3. And obviously you could check it by plugging it back in. And the beauty of that Cramer's rule is, like if you get fraction answers or something, it doesn't matter. It's already a fraction. And the calculation's so easy. So I kind of like that Cramer's rule. One quick note, it also works with 3 variables. Not sure we're going to do those, but if you had an x, y, and a z, you could also use Cramer's rule to solve that. Just a heads up, you could do it. So I'll see you in class tomorrow. We'll work on some of these, and hopefully it wasn't too bad. See you then.